Let's look at the strength. Here we are dealing with the twist, angle of twist, torque, angle of twist, torque, and what? Power, angle of twist, torque, power, rotational frequency, and what? Modulus of rigid, and what? Yeah, so this one are all acting on one object. Okay, there's a length and there's a diameter. So this one use mean. So an object like this can twist or by the external force caused by a torque. Torque, it's a radius times the force that acting on this. So it's like force times radius, it's torque. And then the angle that when it twists, a twist is like something like changed it, the shape of the the shape of the object. If something is twisted, it becomes like slightly change. You know, it's change. It causes the angle to change. So a certain angle that is change is this thing. Depend on how much, but it's changed slightly. And an object can rotate. While it's rotating, we use the rotational frequency. This rotational frequency, when it's rotating, it caused by power, a torque, and the diameter of this one remain the same. The length, yeah, is remain the same. So when we deal with problem, we're dealing with the shaft, different materials. So material have different rigidity, modulus of rigidity. So yeah, that's it. The diameter is this size. The length is this from here to here. It's the length there. When we talk, let's check some of the problem that we have here. So maybe can explain better some of the problems. So checking here, we are asked and let's we are given, and this is the statement. So the statement says a 50 millimeter shaft with the length of this rotate at this, and the allowable angle of twist is this. So the allowable angle of twist is there when it twisted. So it twists slightly when it's rotating. So there's this twists. So the maximum torque and the min torque is there. There's a relationship between this. This is 15%. It's 1,5. Listen, so here we have the diameter. This is the diameter of the shaft. So the diameter is this side, and then this one is the length. The length is from here to here of this shaft, and it's rotating. It's rotating, so it depends how it rotates. So it's this one is the speed. It's a rotational frequency, and then we'll have, and this is the rigidity, and this is the torque that it's rotating. So the question said you have to calculate the power transmitted at 500. So let's these things transmit the power. So if it transmit the power, maybe somewhere there's an engine or there's a motor or something like this, so it transmit the power. So maybe generator or something. So the transmission frequency of the motion is this. So this shaft that means it transmits something from one place to another. We don't know what it is. It can be what, anything that can use a shaft. You can say what do you call, conveying belt or something like this, and then yeah, maybe there's a motor at some point here transmitting this. This is the shaft that we are looking at. So it transmit power. So this one, it gain power as this one rotate at this rotational frequency, and there's a torque causing this to turn. So a torque is the force times the distance that causes this to rotate. So this one, when it rotates like this, it slightly change the angle, but it's allowable to change the angle, as the allowable angle of twist to change. So we are requested to find the power. So the power that is transmitted to this point, at this point here, there's a maximum torque, but here before it deliver, it become a mean torque, because it's the energy here, it's different here. So the power transmitted here, that means the power from here to here has been transmitted. So we'll be looking for a mean torque to calculate the power. So for the maximum torque is the torque that at this point. So in the torque that at this point, it will use the equation this, and this is the equation for rigidity, for angle of twist. This is the length times t torque. It's not, no, this is torque, and this is rigidity. And so we are looking for this torque. So to calculate the torque, you can, let's draw something like this. You can use you can make the 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 torque the subject of the formula. So to make torque the subject of the formula, you have to do some calculations. Because this torque does not have a hole, so it's like this. So if it have a hole, you'll use the other formula that have two diameter. The inner diameter one is the outside diameter. So because there's a force that act there, so at this point you want to make this one the subject of the formula. So you have to remove this thing and leave this T marks the subject, the subject of the formula. So to remove this one, you have to multiply by the same thing as this, but inverted. So to remove it, you have to say g over, you remember in maths what you do, both what you do on the left must do it on the right, so just invert this one. So I think it's easy this way. And then it's like this, because you want this one to be the subject of the formula, so you don't even touch this one, you just remove the one that's on one side. So this will cancel this one will cancel this one, so you are left with T max. So you can take the T max to the other side if you can understand this one. So it's the same thing, doesn't matter whether it's this side or this one, but we used to calculate this side, and the subject of the formula must be this side. We used to this and then multiply by, and then L is multiplication. So this one we are given it, so we have to convert it. You have to convert it. So you'll have something to convert this one, you'll have something like this. It's 1,7 multiplied by pi over 180. So we have to multiply this one using a calculator, and let's see with the calculator how it's. Can you calculate this? 1,7 multiply by shift okay, and then divide by 180, and then what's the answer is 0,0296. Converting this is 97, so it's like this. So you have something like 0,0297 for the angles. Remember, we're looking for a torque, so we have to make. So from this point we can come to this equation. So you'll have something like Q max equals to the G. It's we're given as what, 93,93. So we are right here, 93, because it's the unit is in gig. It's times 10 to the power 9, and then multiply by, and then because the D it's in millimeter, so I have to put it in meters. So to change this one to this D to converting this one, you'll have to it's 50 divided by what call 1000, and then you have 0,05. So I have something like 0,05, and then putting 0,05 raised to 4, and then our angle it's this one, 0,0297 all divided by 10,2 times length. The length is 1,5 from this statement is 1,5 meter. So we'll have something like 1,5 here. So I am trying to calculate. Let me try to calculate the top part before the bottom part. So calculating the top part, you say 93 xp to the power 9 multiplied by 0,05 raised to 4 multiplied by 0,029 7 equals to, so I have something like 17263,125. It's 17263,125 divided by this one. What is 10 times 1,5? 10,2 multiplied by 1,5 equals to 15,3. So the final answer is 17263,125 divided by 15,3 equals to, it's 1128,3. So the unit for this one, it's Newton meter. Newton is for the force, meter is for the radius, same as force times. So if you don't know what is, you can also find it from this one. If you know the unit, what is the equation for this one? It can be force times distance, which is okay. So from here you have this one, from this point, because we have calculated the maximum, it's from the starting point, it's from here, the maximum. So we are looking for the mean. So the mean, we are told that it has a relation with the maximum, but it's 1,5. The mean is right. This one is the maximum. Okay, this is the mean. And this is the max. Okay, so now we have the max, so we have to find the let me see, it's something confusing. 1,5. It was correct. Yeah, it's correct this way. So you have the maximum, you find the mean, you divide by 1.5. It's correct. So you have something like this. This is 1,5. This is T max. So you are looking for the mean. You'll divide both sides by 1,5, and then this one will delete this one, so you'll have something like 128,3 divided by 1,5. So you'll have something like this. 1,128,3 divided by 1,5. It's not 1,5. This is 1,5. And then you'll have what? 752, 2 meter. So this is your mean. Now you can calculate your power. So you have to know the equation of power. This is your mean. Then you're still going to calculate the power. So the equation of a power is, this is the equation of power, because it's the rotational frequency, it's a rev per minute. To convert it to second, you divide by 60. So you have to check whether this one, you have to check it. You don't just put 60 here. So you'll have something like 2 pi, because our ref, it's 500, and then the torque is the mean torque, which is this one. It's, and then divided by 60, and then you can put this one in a calculator. Okay, I'll just clear the calculator, and then calculate. So it's 2 times shift pi multiply by 752,2 I forgot the 500, and then divided by 60. Then what is so the power is 39,38,5,1 39,38,1, because it was 0,99999. That it was 0,999, so it's convert to 1. So the power, the symbol for power, it's a watt. But this one you can also convert it to kilowatts. You calculate is equal pi 725. Okay, it's 5, it's missing. I didn't put the 5 here. Okay, it's 39,38,5, so it's the same as, let me write it, 39,38,5,1 watts. So converting to kilowatts, you'll divide by 1000. Just 1000 is how many zero? There are 3 zeros, so we'll say 1, 2, 3, so the comma is here. You can leave it to 39 or 35. Let me say 8, right? 5 kilowatts. So this is the power they were looking for. A transmitted power. They said it's transmitted. Input power, transmitted power. Okay, now they are asking for the maximum shear stress in the shaft. A shear stress, a symbol like this, it's a shear stress in this, they are represented by this symbol. So a shear stress, it's a stress but in different. So a shear stress has an area. It's a stress have an area. So there's some of the equation of the shear stress. So this is, let's say it was 1, question 1, I'm not sure. So number 2, shear stress. So shear stress is this symbol. And then divided by pi d cube. So if we are asked for shear stress, use this equation. We have this maximum, we have this one. So we can just copy and paste the T maximum as this one. This is the T maximum. We have 1128,3, so we'll have 16 times 1128,3, and then divided by pi, and then what is the diameter? It was 0,0. Yeah, it's like this. And then calculating the shear stress using a calculator, you'll have something like 16 times 11 to 8,3, and then divided by close brackets, put everything here, shift 0,05. This is okay, let me see, multiply by 0,05 raised to 3, then the answer. The shear stress is big. It's 49 like this. It would be 45,971,077,71 Pascal. So this one can be converted to a mere something. Okay, it stops here. Okay, it can be sent to megapascal. So you have a comma here. How many megapascal do we have? Zeros to any mega. Mega have 6 zeros. Mega million. Mega is a million. So you'll have to go back to in 6 times 1, 2, 3, 4, 5, 6, your comma will be here. You start from here, 1 2 3 4 5 6. You can convert it with a calculator, you'll see you'll get the same thing. So you'll have megapascal. Yes, this is how you calculate the shear stress from this shear stress of in the shaft. A shear stress is shear stress. It is the stress that can cause to cut the shaft. So that's how we calculate deal with problem like this. So you can check similar problem related to this. Know the formulas. If you know the formula, you know the chapter. You can try to make your problem simpler if you know the formula, you know the chapter, so you can compare. This is how it can be done.